Okay, well, we're back. So today is going to be a short presentation, but it's going to have a lot of good information. We're going to begin by looking at homework number 2, showing you some of the solutions that you came up with. And then we're going to go on to giving you the idea behind homework number 3, an extension of homework number 2 using states to sequence the gyro and accelerometer data. Now, you might remember that Rob Sullivan and company are working on a guitar tuner, and we're going to also show you a Simulink way of solving that, also by using state sequencing and state flow. So let's get into this. Well, first of all, homework number 2. Here are some of the solutions the students came up with, and they indicate the first one here is switching the X, Y, and Z axes of either the gyro or the accelerometer, doesn't really matter, into a common line. And then the other way that we can do that is we can use this system here and basically just input a 1, 2, and 3 into a multiport. So we replace the switches with a multiport here. And then finally, the way that I recommend for homework number 3 coming up is just basically type in a number here into the select line of this multiport, and that will give you the information. By the way, the select line into the multiport is basically a multiplexer, although the multiplexer is defined by this company, by MathWorks, is actually a different device that doesn't even have a select line. So it gets a little confusing, especially if you're a computer engineer. Now, how does this apply to homework number 3? I just discussed this just a bit. So here's the outline for homework number 3. What we're going to ask you to do is take your old homework number 2 and add to it a state sequencer that is going to allow you to move between sequencing the x-axis, the y-axis, and the z-axis data. Now, we're going to use an example, and this turns out to be an easy assignment because not only is the example specified, but I'm going to give you the software for this example. And this example is actually a traffic light control system, which is actually shown over here. So I'm talking about this step here, this first idea here. So in this example, I'm going to show you here for a second, uses a state diagram. And in this particular case, you're going to start over here showing, obviously this is traffic control light, so we're going to turn on the red light, then we're going to go to yellow, which they call orange, and then we're going to go to green. I guess in some countries the yellow is actually orange. And there's a specification here for holding it for 5 seconds, holding it for 2 seconds, and then returning after 5 seconds. Well, we're going to use that exact same thing here in this problem here. I'm going to ask you to stream the X and the Z data for 5 seconds and the Y data for 2 seconds. Okay, so you can make use of this. Now, if you think about that switch that we just thought about that, and the switch, if you change this number here, okay, from 1, 2, and 3 in this diagram, then instead of having 3 different outputs, red, orange, and green, you can just have one output that changes 1, 2, and 3. Okay, so basically this is a trivial assignment, but it's fun to set it up, and it's always good to give students something easy that they can know to work with, being that this is kind of at a high level to begin with. And so I'd like you to demonstrate your design to me on a time scope, or you can go back to that dash scope that we used on the homework number 1 if you want to plot that down, and let's go with that. So I want to point out to you where the software is. So if you click this link here, and I did that, so let's kind of go over there right now. And so that will be this one, I think. And so this gives you the setup for this. So in particular, let's take a look at that. But before I forget it, let's move our cursor over here, and this is where you can download the actual file that will do this problem here. So let's go ahead and click this now. And so this is the setup. You're going to use your are doing omega or do and make the connections, what you're going to do is drive 3 outputs, one for the red light, the yellow light or orange light, and the green light, and make sure you have your resistors in there. We had some students in the past forget that, and they burn things out. So let's not do that. So that is the very easy setup, and you're provided all this in your parts kit. So this should be a fun project to do. All right, so that's what I wanted to demonstrate for you. What else do we have here? Not too much. Here's the file associated with the download that you're going to make. Let's go back to the presentation now. And on the slides I am giving you, I also have that same picture here. Okay, so you're playing the role of Rob Sullivan here, and your sponsor is the tech director, and I'm playing the role of the senior engineer, mainly the person that's overseeing everything. And so Rob is involved in a project called a guitar tuner. And so they're developing this product, and you're kind of developing your product, and I kind of want you to compare the ideas. Now, one thing I want you to remember is not to forget to find a project. And I think we've got 2 groups, and we got 4 groups. We got left that don't really have a project yet, and I've sent information concerning the projects that are available. Let's say that I think you need to come to some decisions by the end of the week here. By Monday, I want everybody to start filling out the forms. And so let's take a look at those forms one more time as I flip back over to the web page and go to this one over here. And so very first form, we had one group fill it out, is the basic project idea. Okay, and then wait for me to respond to it and give you the go-ahead to look at it. And then the second one will be the background statement. Okay, so we'll be talking about that background statement form and how Rob Sullivan actually is looking at it. Rob Sullivan is going to go in this example in the appendix of the book, does Google Form 2, 3, and 4. Of course, at the time the book was written, there was no such thing as a Google Form, but we will use the Google Form to expedite things. Okay, so Rob and the salespeople came up with this idea of a user interface and a box maybe that would hold the instrumentation. And basically this instrumentation is going to indicate if you have a sharp or a flat tone on the 6 strings of the guitar, and you can tune it. And based upon that, namely you, are going to assemble this information, and you're going to write a statement of the problem. Basically, we're not trying to solve the problem right now, and I know that that's hard to stop doing, but basically we have to describe what the problem is. So as I've described in past times, the Google Form number 2 is associated with writing a background statement, which is just what you see right in front of you right here. So the example that I want you to follow is these 2 paragraphs here that I'd like you to write, and make sure you don't use the word I or we or our. That's not appropriate for an engineering documentation, despite maybe what they told you in English class. And this will all then fit in very nicely with your next assignment in the writing area, which is to do Google Form number 3, which is shown by the number 3, which is also illustrated on the next page that you don't have to do right now. And that finishes that particular section off. To show you where we are in the big scope of things, let's go ahead and bring this diagram up. So again, Google Form number 1 is the project idea, and then Google Form number 2 is the background statement. Now the background statement is graded. Google Form number 1 is not graded. And so to show you where you're at with 1 and 2, 1 and 2 is indicating you're working with the customer, you're assessing their needs, you're trying to figure out what exactly the problem is, and this is as far as we've gotten so far. Eventually, when you write a complete statement of the problem, right now you're just doing a background statement, so you're just doing this background right now. Okay, so that's easy. And eventually when you do number 3, then you're going to be able to start looking at what the design requirements are. You're going to take that back to your sponsor. They are going to get an interface with you. And so this loop goes. Now, this brings up some idea here. Some students would like to do their own self-sponsored project. Well, that's allowed, but it's not as good as having a sponsored project simply because you are you and a sponsor is somebody else. And when you are you, then it's easy to have this conversation here because you won't have one. So in order to get the full benefit of the course, it's great if you had a sponsor. That sponsor can be kind of overseeing you a little bit and providing you funds, hopefully. And so you miss this part here if you self-sponsor a project. So see what you can do about getting a sponsored project. And I sent you some, as I mentioned earlier, some ideas with that. So let's continue on now. And basically the book is carries through some ideas on how they are going to handle this project. And let's see where we're at. So Rob Sullivan is trying to understand what the problem's all about. Rob Sullivan is you, and he's quite aware that a care must be taken to produce a understanding of the problem, a problem specification that is very realistic. He decides to measure the sound volume, and as all good engineers do, they take it home with them, and Friday night and Saturday night they work on these things. And he looked at the sound volume, note duration. He's just trying to get an idea of what's going on, and he wants to find out what are the key measurements that need to be done. Well, he's able to instrument this up a little bit. If you read this in the textbook, which is in the appendix, and he records some measurements, basically 2 feet away, facing the guitar box, and he's got some specifications here, and he makes some recording of this, okay, which is actually these days extremely easy to do. It's actually quite amazing that he was able to do this some 25 years ago or so. So maybe a little bit less than that. So this gives you an idea of the waveforms he was generating. This is a waveform showing the 5th string to a quarter second, and this is the waveform of the 5th string up to a full second. He begins to think about how the problem could be set up, what kind of problem would lead itself to a good solution, etc. He fast Fourier transforms are just been in the foray, and he's thinking a little bit about that. That will turn out to be a solution that he'll look at eventually, but there's no solutions right now. We're just looking at the problem, and so he begins to somehow he has this available. He can take the fast Fourier transform and get an idea of how this works. So here's your on the frequency basis. He's analyzed the first string at 110, the second string at 220, the third over here. The fourth, hey, by the way, these 110 and 220, it's the same number as AC. That's interesting, huh? Guitars and power have similar numbers, and etc. And then there's some other harmonics associated with that. Well, these days we advance another 20 years, and we have actually easier ways of being able to do this because we've got programs that can organize a block diagram and even do a simulation. I actually found one for you to look at. And it's called Automatic Guitar Tuner using an Arduino and Simulink. Unbelievable, just exactly the kind of things that you guys are looking at. So here's our modern Rob Sullivan, and there he is. He's already developing some things here, so we will pretend that we're not doing this just yet, but this is kind of the lead-in photograph. And so this is his block diagram that he's doing. He's going to do something similar. He's going to light up some LEDs indicating what string, in this case, what string they're operating on, but not sharp or flat. So how does he handle that? Well, he's got a push button over here that will activate the system, and he's got the guitar input, which Rob Sullivan also did. What he's going to do is he's going to indicate what string he's going to operate, and then he's going to say, wow, what would be the easiest thing to do? Well, it'd be great if it's just the key would just turn itself and then turn to the right position to get the right tone. Well, he is imagining that he can do that and attach that to the guitar and see if that can be done, such as in the photograph that I just showed you up here. Okay, so this is the mechanism that he's imagining that he can do. So this is kind of a real rough block diagram. This is what he's thinking about. He's not trying to solve the problem. He's just trying to come up with an idea of how to do that. So let's see a block diagram. Now he whips out the modern version of Rob Sullivan, whips out his or her Simulink and indicates the two things that we will have. We're going to set up 3 blocks. And this block are going to be inputs into the Arduino. This blue block are going to be outputs out of the Arduino. So one of the input is going to be the push button to start things. And then down here is the output of the guitar and being read into the Arduino. Isn't that cool? And so then the outputs are indicating LEDs, 1, 2, 3, 4, 5, 6 LEDs. So we'll indicate what LED we're working with. And then look at this. We're going to imagine we're going to connect this to a motor, a step motor, and I will be able to tell it to get enabled, as well as go in one direction or turn the motor in the other direction. Okay, so this block here would be a gray block, and that would be basically the design, would be the block diagram description of what's going on. Now, because this is actually a Simulink tutorial, there's actually more details in here. So the more details would not be probably be envisioned as a problem statement as the time that we're in right now, is indicating that we're going to have a state diagram that's going to go from state to state and then investigate the low string, the second string, the third string, fourth, fifth, and sixth strings here. And then down here, we're going to have some mechanisms for turning the motor. So those details would be part of your design work, and implementation of that would be actually next semester. So this is going a little bit beyond, but that's okay. We can imagine that we certainly have a gray box here, and we have the orange box and the blue box. So let's look at the states here. We certainly would do this. And at this point now, we are talking about the same kind of ideas that we had back in our homework. Okay, so here we are with homework number 3, and we've got these 3 states. And here we are in Rob Sullivan's, the new Rob Sullivan's example, and we have 6 states. Okay, so this is the match I want you to see here, that we are very relevant. We're just drawing blocks, we're drawing states. We're not trying to solve the problem yet. We're getting an idea, basically how to address the problem, how to specify how the problem should be, and understanding what are the limits and parameters associated with this. So basically we go from one state to another state, which is one string to another string, and we do some analysis inside there, and we can turn the motor. How that's done is the next step, is the step of actually solving the problem. Okay, so that pretty much is what I wanted to share with you, except maybe show you 2 more diagrams corresponding to the diagrams that we got over here, where Rob Sullivan took this home and looked at some waveforms in Simulink. We can do that also. And so here we use an audio scope for that, and there it is. And instead of using a fast Fourier transform, I believe the way that the problem ends up being solved is it measures the period of the waveform, and that period again then is adjusted by turning the key on the guitar until it matches the period that it should be. Well, that's enough on that. That gives you an idea. Hopefully this kind of puts the whole course into a mega organizational, where you're working at how learning how the engineer is thinking. You're looking at how it was solved 20 years ago. Now you're projecting it to the modern ways of tools of using, and we're seeing that all these ideas are coming together, and we're really trying to make everything work. So we will see you again, and this is the information that you need for this week.